Imagine you're writing a video game code and you just want to draw a character on the screen. But without an operating system, you don't have a screen, you have millions of individual pixels that need specific voltage instructions. To make sound, you'd need to manually vibrate the speaker membrane, and to save progress, you'd have to physically position the hard drive head. And here is the real problem. If two programs try to use the hardware at once, they crash into each other. We need a buffer, something to hide the messy hardware details and referee the chaos. This is the operating system, essentially the government of your computer. Pause and predict. If the hardware is a pile of raw resources, what is the OS actually managing? It manages resources, turning raw hardware time and space into abstractions we can actually use. A common misconception is that the windows and menus you see are the OS, but they aren't. They are just programs, while the OS is the invisible puppeteer pulling the strings behind them. No matter what app you run, the way they talk to the hardware is exactly the same. They ask the OS for permission. Let's see this in action. When you hit save in a word processor, the app doesn't know how to spin the hard drive. Instead, it makes a system call, switching from user mode to kernel mode, basically handing the keys to the OS. The OS checks if you have permission, finds free space using its file system map, and translates save this into electrical signals for the disk. Once the hardware finishes the job, the OS hands control back to your app saying done. This loop happens thousands of times a second, creating the illusion that your computer is doing 10 things at once when really it's just switching attention incredibly fast. So the operating system is the bridge that turns complex hardware into usable software abstractions. It protects the hardware from you, and it protects you from the hardware.